Hello everyone, welcome to Vidhyalakshmi YouTube channel. Myself Moses, chemistry teacher here. Today I am going to discuss a topic called hydrogen bonding. What does it mean by hydrogen bonding, right? All these things we'll discuss later, but why do we have to make a video on only hydrogen bonding itself means it plays an important role not only in organic, inorganic and physical chemistry, okay? In entire chemistry, right, it plays an important role, okay? You can also be reading about the hydrogen bonding in biology, in biomolecules. You can also be reading about hydrogen bonding about the stability of the molecules. You can also be reading hydrogen bonding about the acidic nature of acids. In everywhere, right, most of the cases hydrogen plays an important role in chemistry. Not only in chemistry, in biology also we can say. Okay, and let us start our topic today, the hydrogen bonding. Most of the students get confused here. What does it mean by hydrogen bonding is, it is not something like hydrogen bond formed with some other hydrogen or some other atoms here. This is not the hydrogen bonding which we are discussing. It is just a covalent bond with the non-metals or ionic bond with the non-metals over there, okay? But here it's an electrostatic attraction between. It's electrostatic attraction means what? Okay, the attractions between two oppositely charged species, right? Electrostatic attraction between partially positive hydrogen should be partially positive here, partially positive, and partially negative, more electronegative atom, partially negative, more electronegative atom. It might be anything, okay, more electronegative atom. What are those more electronegative atom also we'll discuss later. Now, hydrogen should be bonded with some other electronegative atom, and hydrogen should get the partial, what we call, partial positive charge over there. When it is charged something like this, right, there might be a force of attraction formation takes place, right, between two oppositely charged. That is what we are calling it as electrostatic attraction, right. This particular attraction is going to be hydrogen bonding. This particular attraction is known as what? Hydrogen bonding. Okay, let me read it again. The electrostatic attraction between partially positive hydrogen and partially negative, more electronegative atom is called hydrogen bonding. Okay, let us see the next slide. Now, hydrogen bonding is indicated with in formula by broken line. Hydrogen bond is indicated in formula by broken line. For example, if you take this hydrogen connected with fluorine, okay, if you take this hydrogen connected with fluorine, right, fluorine is highest electronegative atom in the periodic table. Now, for example, when hydrogen is connected with more electronegative atom, what happens? The shade pair shifting takes place towards more electronegative atom, and fluorine gets partial negative and hydrogen gets partial positive. The same thing here also happens. The shade pair shifting takes place towards fluorine. Fluorine gets partial negative and hydrogen gets partial positive. Okay, when this partially positive and partially negative species comes close together, right, there is a formation of electrostatic forces. This electrostatic forces between more electronegative atom and the partially positively charged hydrogen is known as what? Hydrogen bonding. This is known as what? Hydrogen bonding. This hydrogen bonding in formulas will be indicated with a broken line. The broken line which we have indicated here, this is nothing but what? Hydrogen bonding. Okay, in the case of second example here, hydrogen is connected with oxygen, the second most electronegative atom in the periodic table. When it is connected with the oxygen, the shade pair shifting takes place towards oxygen, and what happens? Oxygen gets partial negative and hydrogen gets partial positive. The same thing happens in this molecule also. This is partially negative, this is partially positive. Between partially positive hydrogen and partially negative, more electronegative atom, there is a electrostatic forces by which it can form the hydrogen bonding. This hydrogen bond can be notated with what? The dotted line, right? Now, let us see the next examples here. Okay, in hydrogen bonding, hydrogen atom gives us a bridge between two electronegative atoms. First, if you take this particular hydrogen here, okay, beside this one, this is a more electronegative atom here. Like right side we have electronegative atom, right? This hydrogen acts as a bridge between two electronegative atoms here. Okay, now holding up by one is pure covalent bond and another one is what? Purely electrostatic force. What does it mean by? Let us see here. What does it mean by? Let us see. Okay, the first hydrogen which we have here, this one is connected with oxygen with a covalent bond. This is covalent bond. Okay, the hydrogen which is attracted by this particular partially negative oxygen here is connected with what? Electrostatic force. This is electrostatic force. What does it mean by? This hydrogen is holding by what? One is covalent bond and the other one is what? Partially what we call purely electrostatic force. Okay. For hydrogen bonding, right, to be important, both the electronegative atoms must come from what? The group called fluorine, oxygen and nitrogen. Okay. In the beginning, I have given a statement or a definition for the hydrogen bonding that the hydrogen bonding is nothing but the electrostatic attraction between partially positive hydrogen and partially negative, more electronegative atom, right? Those electronegative atoms should be fluorine, oxygen and nitrogen. Means hydrogen should be connected with fluorine, or hydrogen should be connected with oxygen. Okay, hydrogen should be connected with nitrogen. Any of three bonding should be there. Hydrogen should be connected with fluorine, or hydrogen should be connected with oxygen, or hydrogen should be connected with nitrogen over there. In these cases only mostly we will be seeing hydrogen bonding. Okay, remember this point. Then let us get into the next slide here. What is this here? Conditions for the formation of hydrogen bonding. Okay, we have seen what is it meant by hydrogen bonding, and we have seen where it is forming, and let us see the condition by which hydrogen bonding can be formed, right? As we have already discussed, hydrogen bonding, electronegative atoms must come from the group called this. We have already discussed this point, fluorine, oxygen and neon. Molecule should possess both acceptor and donor units. Okay, we have two terms here. This is acceptor unit, another one is what? Donor unit. Okay, the molecule which is going to form hydrogen bonding should possess two units. One is acceptor unit, second one is donor unit, right? What is meant by acceptor and donor unit in the molecule which is going to form hydrogen bonding? Now if we take this particular example over here, now oxygen is connected with hydrogen here and it contains lone pair, right? This hydrogen is known as, with more electronegative atom, it might be oxygen, fluorine or nitrogen. This is known as donor unit. And the lone pair on the more electronegative atom is known as acceptor unit. The molecule which possesses these two units, right, that can easily form what? Hydrogen bonding. Now if we take this one, right, we have an acceptor unit and we have three donor unit, because of which ammonia can form hydrogen bonding. Okay, these two must be there to form a hydrogen bonding. Okay, now let us see some other examples over there. Okay, there is a question: which of the following molecule forms a hydrogen bonding? Okay, hydrogen bonding present in, we have four molecules over here. Okay, in which we have one more electronegative atom here and here. Okay, we have more electronegative atom. Out of all these things, right, in which hydrogen bonding can be possible. Okay, now if we take fluorine, right, we have fluorine here which comes from the more electronegative group. Okay, fluorine is there, but what is the condition? The hydrogen should be connected with the more electronegative atom. Let us take, this is X. If X is fluorine or oxygen or nitrogen, right, then we can say it can form readily hydrogen bonding over there. But we have fluorine here, but there is no hydrogen which is directly connected to fluorine, right? There is no hydrogen which is directly connected over there. Since there is no hydrogen which is directly connected to fluorine, right, the first one won't form the hydrogen bonding. Let us take the second example here. We have an aldehyde over there. Here hydrogen is there. Many of the students will get confused here. Okay, hydrogen is there and electronegative atom also is there which can form the hydrogen bonding. But here the hydrogen must be connected to oxygen, not to the carbon. That's what this one also won't form the hydrogen bonding. And if you take the third one, right, we have oxygen where it is directly connected to hydrogen over there. Okay, when oxygen is directly connected to hydrogen, what happens? Shade pair shifting takes place towards oxygen. Oxygen gets partial negative charge and hydrogen gets partial positive charge, by which it can form the hydrogen bonding. Right? That's what third one forms the hydrogen bonding. And what about the last one? We have nitrogen, more electronegative atom, and we have hydrogens, not with the more electronegative atom, but it has connected with what? Carbons over there. But what is the condition? The hydrogen should be connected with more electronegative atom. But this one also won't form the hydrogen bonding. But what do we have here? The hydrogen bonding present in means what? The third molecule, the acid, the ethanoic acid which is there, this is only going to form the hydrogen bonding over there. Okay. Now let us take the next example. Let us take the next examples here. Okay. Let us take the next question here. What is this? The strong hydrogen bonding present in. The hydrogen bonding is purely electrostatic in nature, right? Electrostatic means what? The bond between two oppositely charged species. Okay, as what we call the magnitude of charge increases, as magnitude of the charge increases, strength of the hydrogen bonding is going to be increased, right? Now if you take all these things, how can we consider the magnitude, right? Now in all these things hydrogen is common, but what is being changing over there? The electronegative atoms over there. Anyhow the third one won't form the hydrogen bonding because hydrogen is not connected to more electronegative atom, as we have already discussed. But if you take the first one, second one and the last one, right, for A, B and D over there, in which we can expect the hydrogen bonding over there. Out of these three, in which the strongest hydrogen bonding is present. Okay, now if you take the electronegativity of fluorine here, it is almost 4. If you take what oxygen, right, it is almost 3.5. This one is going to be almost 3. Okay, now in which case we have more electronegativity difference means the last one we have more electronegativity difference over there. Since we have more electronegativity difference in hydrogen fluoride, right, the magnitude of charge or dipoles is going to be more. That's what we can expect the strongest hydrogen bonding in hydrogen fluoride. Now let us take next example. Let us take next examples over here. Okay. Yeah, you wouldn't have heard of this term, right? The perfect hydrogen bonding. Okay, the perfect hydrogen bonding means equal number of okay, donor and acceptor units. Okay, we know donor units means hydrogen connected to the more electronegative atom. Acceptor units are nothing but the lone pairs on the electronegative atom. We know this one, right? If you take nitrogen, right, nitrogen with 3 bonds will have 1 lone pair. Okay, hydrogen will have 2 lone pairs, and fluorine will have 3 lone pairs, and alcohol will have 2 lone pairs. Oxygen will have 2 lone pairs in the alcohol, right? Now out of all these things, right, in which we can say same number of electron pairs and donors, hydrogens over there. Okay, now if we take the first one, right, the ratio between lone pair and hydrogen is 1:3. The ratio between the hydrogen and oxygen is 1:1. The lone pair and the hydrogen's ratio is 1:1. If you take this one, the lone pair and the hydrogen, right, it is 1:3. If you take this one, the hydrogen and the oxygen lone pair is 2:1. Okay, in which case we have same number of ratio, the equal number of what we call donor and acceptor units means the second one, the water forms perfect hydrogen bonding by having equal number of what? Lone pairs and hydrogens. Next. Okay, let us see some of the example in which hydrogen bonding is possible. Now we have H2O here. In H2O we have 2 lone pairs and 2 bond pairs are there with the hydrogen, right? We know this hydrogen acts as the donor unit in the water molecule and lone pair acts as what we call acceptor unit. Since water contains both donor and acceptor units, right, that's what hydrogen bonding is possible in water. If you take the second example, right, NH4 ammonium ion is there. In ammonium ion we have only donor units, not the acceptor units, right? If donor units acceptor units are not there, for formation of hydrogen bonding both the conditions should be maintained, right? What is that one? Donor unit and acceptor unit should be there, but here we have only acceptor unit, only donor unit is there but not acceptor unit. That's what this one won't form the hydrogen bonding. But if you take the third one, right, it has 1 lone pair and 3 bond pair with the hydrogen, right, then it can form the hydrogen bonding. If you take this one, we have lone pairs and bond pairs, 3 lone pair and 1 bond pair is there with the hydrogen. If you take NH3, right, we have acceptor unit and donating unit, it can also form hydrogen bonding. But here we have hydrogen and more electronegative atom. But the thing is, hydrogen is not directly connected to more electronegative atom. Now we have fluorine with acceptor unit but not the donating unit, which is hydrogen directly connected to the fluorine, right? That's what it won't form the hydrogen bonding. Now let us take this one, right? It is also similar to this one only. Fluoroethane, this is fluoromethane. Here also we have what? Only acceptor units, right? But not donating units. If you take the methanol, right, alcohols, what do we have? We have acceptor units and we have donating units, hydrogen over there. That's what it can readily forms the hydrogen bonding. If you take the isomers of alcohols, right, functional isomers of alcohols, we'll get ethers. Ethers have oxygen and hydrogen, but not the hydrogen which is directly connected to oxygen, right? We have only acceptor units, okay, not donating unit. That's what it won't form hydrogen bonding. Now, if we take this one, right, acetaldehyde, the bond should be connected to here. As we have hydrogens and oxygen, but hydrogen is not directly connected to oxygen. That's what we can't expect hydrogen bonding in this case, right? Let us see some other examples. Okay. Now we have acetone is there. We have double bond O and we have hydrogens over there. But here electronegative atoms are there and hydrogens are also there. But hydrogens are not directly connected to oxygen, but only we have acceptor units, but not of the donating units. It won't form. And if you take H2S here, hydrogen sulfide, it has, what is this? Lone pairs and it has hydrogen. But as per the conditions, as we have already discussed, what is it? What is that? The hydrogen should be connected with more electronegative atoms as oxygen or fluorine or nitrogen, right? Any one of these three atoms should be there with the hydrogen. But here, hydrogen is there, but not the more electronegative atom over here, right? That's what it won't form the hydrogen bonding. Okay, we know H2S gives a kind of rotten egg smell, right? And it is a gas at room temperature. The reason behind is it won't form hydrogen bonding, right? Then, if you take alcohols, right, as we have already discussed in the earlier example, it can form the hydrogen bond. Okay, yeah. Next, okay, let us see these examples. Okay. It is also similar to the previous examples only. We can't see any kind of what we call electronegative atoms here. Here, electronegative atoms. That's what it can't form the hydrogen bonding. Here also no electronegative atom. It won't form the bonding. But here it can form the bonding because hydrogen is directly connected to more electronegative atom, and it has two lone pairs over there. It can readily form the hydrogen bonding. Next. Okay. Let us see these examples, right? We have cyclohexane and many other examples are there. Here in the cyclohexane, right, there are no electronegative atoms. We can't expect hydrogen bonding. Here we have electronegative atom, but there is no hydrogen which is directly connected to oxygen. It won't form again. If you take this one, right, here we have nitrogen. In nitrogen, lone pair is present, that is acceptor unit is there, donating unit, both are there. All the conditions are satisfying. That's what it can readily form hydrogen bonding. Now here we have acceptor unit, but not the donating units. There are no hydrogen which is directly connected to nitrogen, right? That's why it can't form the hydrogen bonding. If we take this example, right, here we have acceptor unit and donating unit, it can form the hydrogen bonding. Okay. Now if we take this example, right, here no hydrogens are directly connected to nitrogen, right? We have only acceptor unit, no donating unit. That's what it won't form the hydrogen bonding, right? Let us see the next example. Let us take the next example. Okay. Here we have acceptor units, okay, with the lone pairs and the negative charge, but there are no hydrogens directly connected to the oxygen. That's what we can't expect hydrogen bonding in these two molecules, ions. Okay. Next, we have now discussed what is meant by hydrogen bonding. What are the conditions required to form the hydrogen bonding, right? If molecules forms the hydrogen bonding, right, what type of hydrogen bondings are possible? What type of hydrogen bondings are there, right? We have two types of hydrogen bonding. One is intermolecular hydrogen bonding and second one is intramolecular hydrogen bonding. Intermolecular hydrogen bonding and intramolecular hydrogen bonding. Okay, what does it mean by intra and intermolecular? By name itself we can say inter means between the molecules, intra means within the molecules. All those things we will discuss now. Okay, let us take the intermolecular hydrogen bonding now. Intermolecular hydrogen bonding, okay. Now, when hydrogen bonding takes place between different molecules of the same or different compounds, okay. Okay, if hydrogen bonding is formation is taking place between the molecules of same kind or different kind, that is going to be what? Intermolecular hydrogen bonding, okay. For example, if you take ammonia, right, if you take ammonia, since hydrogen is less electronegative, electron sharing movement takes place towards nitrogen, nitrogen gets a partial negative and hydrogen gets a partial positive here. Similarly, hydrogen electron shifting takes place towards nitrogen, nitrogen gets partial negative and hydrogen gets partial positive. Between these two, what happens? Hydrogen bond formation takes place. Okay. Now the hydrogen bond formation is taking place between the molecule, right? That's what this hydrogen bonding is known as intermolecular hydrogen bonding. intermolecular hydrogen bonding. If you take this one, right, HF, let us take two molecules of HF here, HF and HF. What do we have? Electron shifting takes place towards fluorine. Fluorine gets partial negative and hydrogen gets partial positive. Here also same thing, hydrogen gets partial positive and fluorine gets a negative charge. And between these two, what happens? Electrostatic forces formation takes place. This is known as what? Hydrogen bonding. But it is taking place between two molecules, right? That is what? This is known as intermolecular hydrogen bonding. If you take these examples also, we have two alcohols here in which oxygen is more electronegative atom, gets partial negative, and hydrogen is partial positive. Here hydrogen is partial positive, oxygen is partial negative. Okay, between these two, okay, electrostatic forces formation takes place. This is nothing but what? Hydrogen bonding here. This hydrogen bonding is taking place between two alcohols, right? That's what we are calling this one as what? Intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Okay. Okay. Here also we can see here. First we have acid. Where oxygen and hydrogen is directly connected. Hydrogen gets partial positive and oxygen gets partial negative. Here oxygen gets partial negative, and hydrogen gets partial positive, here partial negative. Between these two, what happens? Hydrogen bonding formation takes place. Between these two also, hydrogen bonding formation takes place. That's why, this is the reason why acetic acid exists as in dimer form. Okay, because of the hydrogen bonding. Okay. Now if we take para substituted benzene, right? Okay, with hydrogen formation over there, what we can see here, it is actually oxygen. It is actually oxygen over there. Okay, we have OH group here. In OH group, what happens? Shared pair shifting takes place towards oxygen, and hydrogen gets a partial positive, and here it is a partial negative charged. Is it partial negative charge? Here also shared pair shifting takes place towards oxygen, partial negative and partial positive, right? Between these two, what happens? Between these two, force of attraction formation takes place between partially positive and partially negative electronegative atom over there. Here also formation of attraction takes place, right? This kind of hydrogen bonding is taking place between two molecules, right? Between two molecules. That's what we are calling this one as intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Next. Okay. Let us see the applications of hydrogen bonding. Applications of hydrogen bonding. What is the use of knowing hydrogen bonding? Okay, it is not only hydrogen bonding. Here we are discussing about intermolecular hydrogen bonding. Okay, here intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Intermolecular hydrogen bonding increases both boiling point and solubility. If you take this particular image over here, this is an alcohol here. This is water molecule H2O, and what do we have? Okay, here we have what we call alcohol is there. Here oxygen is there. In the water, here what happens? Hydrogen gets a partial positive charge and oxygen gets a partial negative charge. And here the same thing happens. Hydrogen gets a partial positive and oxygen gets a partial negative. Okay. Because of the force of attraction between oxygen and hydrogen between water molecule and alcohol, right? That's what? They are easily soluble in water. Alcohols are soluble in water because of what? Intermolecular hydrogen bonding. Okay. Generally, hydrocarbons or organic compounds are hydrophobic in nature, but some of the organic compounds are soluble in water because of what? Because of formation of intermolecular hydrogen bonding with water. Okay. Now, if you take the boiling point here, boiling point also increases with intermolecular hydrogen bonding. As we have already discussed in the previous slide here, what do we have? It is happening between the force of attraction formation taking place between the molecules. Okay. During the boiling, what happens? The states of matter is all about the conditions which we will apply to the molecules, right? If you decrease the temperature and increase the pressure, the state is converted into solid. If you increase the temperature and decrease the pressure, what happens? It converts to solid to liquid, liquids to gas, right? Here, the forces of attractions are more. Means as they are coming close together, right? As they come close together, they will exist in solid or liquid state, right? To convert them into the respective gases, these bonds should be broken. The attraction should be broken in order to separate them. Right? To separate generally, they require some amount of energy, right? That's what Because of these forces, we need to apply more amount of energy. That is why the compound which possesses intermolecular hydrogen bonding will have what? More boiling point. The reason behind is the force of attraction between the particles. Right? Next. Okay. Let us see some of the examples here. Let us see some of the examples in which we can compare the boiling points over there. Okay, we have atoms of same group, nitrogen, phosphorus, oxygen, sulfur here, oxygen, alcohol and ether, and we have acid. Let us take this one as ester, OR. Let us take this one as ester. Okay. Now, if we take the first atoms of same group, right, nitrogen and phosphorus. Okay, out of these two, nitrogen has ability to form the hydrogen bonding over there. Okay, because of which we can expect NH3 will have more boiling point than that of PH3. And if we take water and H2S, right, H2S exists as gas at room temperature because it won't form any kind of hydrogen bonding. Okay, that is what we can expect more boiling point in water. Means if you take the third one, right, what do we have? We have alcohols and we have thioalcohols, right? Here with the oxygen we can expect the hydrogen bonding, but not with the sulfur over there. That's what the one which forms the hydrogen bonding, intermolecular hydrogen bonding, will possess what? More boiling point. Okay. Here we have alcohol, its functional isomer, ether is there. Only alcohol can form the hydrogen bonding because the hydrogen is directly attached to the oxygen over there. We have acid and ester is there. In the case of acid, hydrogen is directly attached to a more electronegative atom. But here instead of H, we have R over there. Okay, because of which we can't expect hydrogen bonding here, but we can expect hydrogen bonding here, because of which this is the order of boiling point. If you take primary and secondary amines, right, it has 2 donating unit and 1 acceptor units. Altogether 3 hydrogen bondings are possible. But here we have 1 acceptor unit and we have only 1 donating unit. That's what we can expect, only 2 hydrogen bonds, right? Since in the case of first one we have more hydrogen bonding, that's what the first one boiling point is more than that of the second one. Okay, let us take the next one. Next example. Okay. As we have already discussed, the hydrogen bondings are classified into 2 types. One is intermolecular hydrogen bonding and second one is intramolecular hydrogen bonding. The first one we have discussed intermolecular hydrogen bonding and its applications. Let us get into intramolecular hydrogen bonding. Okay, the hydrogen bonding which takes place within a molecule, within the molecule. Okay, if hydrogen bonding takes place within the molecule, what happens? Those hydrogen bondings are nothing but what? Intramolecular hydrogen bonding. Generally, if you take benzene substituted compounds, right, ortho substituted compounds can form hydrogen bonding steadily. Okay, for example, if you take fluorine here, it is highly electronegative, gets a partial negative charge. Here hydrogen is connected to oxygen, where hydrogen gets a partial positive and oxygen gets a partial negative charge here, right? What happens between these two? These two, there is a formation of hydrogen bonding, right? There is a formation of hydrogen bonding. If we take the second example here, same here, what is this? Hydrogen is connected to oxygen. Okay, here hydrogen bonding we have seen intermolecular. Now let us see here. It is partially positive, partially negative. Electron shifting takes place towards oxygen. This is partially negative charge, right? What happens between these two? Hydrogen bonding formation takes place. Since the bonding which we are discussing, the hydrogen bonding formation is taking place within the molecule, right? That's what we are calling this one as intramolecular hydrogen bonding. Now if we take this particular example, okay, electron shifting takes place towards oxygen. This is partially negative, this is partially positive, this is again partially negative, right? What happens between these two? Hydrogen bonding formation takes place. Here also the hydrogen bonding taking place within the molecules. That's what we are calling this one as intramolecular hydrogen bonding. If we take this particular example, right, what do we have? We have partially positive hydrogen and partially negative oxygen. Here what happens? This is partially negative oxygen. Formation of attraction takes place between these two and formation of hydrogen bonding takes place, right? In these 4 cases, what we have seen is that the hydrogen bonding formation is taking place within the molecule. That's why this hydrogen bonding is known as intramolecular hydrogen bonding. Okay. Now in this all we have discussed the intramolecular hydrogen bonding, right? Now let us see some other examples here. Okay, let us see the applications of intramolecular hydrogen bonding. Okay, in the case of intermolecular hydrogen bonding, the solubility and boiling points were high, but in the case of intramolecular hydrogen bonding, okay, it decreases both solubility and boiling point. The solubility and boiling point both are decreasing, right? Now if you take this particular example, right, what is happening? These two are, this is ortho substituted product, this is para substituted product, right? Now ortho substituted products generally forms intramolecular hydrogen bonding, but if you take this one, right, it forms what? Intermolecular hydrogen bonding. Intermolecular hydrogen bonding, right? This is intramolecular hydrogen bonding, this is intermolecular hydrogen bonding, right? Now out of these two, which is more soluble in water or which has more boiling point, if you think, right, the one which forms the intermolecular hydrogen bonding will have what? More boiling point. Okay, the one which forms the intramolecular one will have what? Less boiling point and the solubility in the water. That's what we can expect. The para substituted product is going to be what? Will possess more boiling point. Okay, why is that? As we have already discussed, boiling point is nothing but the conversion of state from liquid to gas, right? Here, to convert from one state to another state, it forms what? Intermolecular hydrogen bonding. Between the molecule, formation of bonding takes place. That bond has to be broken in order to convert them into the respective gases. Now if you take these two also, the first one is ortho substituted one, second one is para substituted one. If you compare these two, right, the second one forms the intermolecular hydrogen bonding. Since it is forming intermolecular hydrogen bonding, right, we can expect the second one is going to be more, possess more boiling point, right? Next, let us take the boiling point order here, boiling point order. The same thing, this one forms, this is para substituted, this is ortho substituted, and this forms intermolecular hydrogen bonding, That's what this one is more, will possess more boiling point over there. If we take these two also, the second one, because of the para substitution, will form the hydrogen bonding readily. Next. Okay, let us take these things also. Okay, no need to worry about all these things. Just see which is like para substituted one is going to be what? Possess more boiling points here. More boiling points. Okay, let us see these examples also. Now if we take these two, right, we have a meta position two hydroxy groups here, hydroxy group, but in the middle we have nitro group. Here we don't have any group, right? When we expect this one, right, we can expect intramolecular hydrogen bonding more. When we expect more intramolecular hydrogen bonding generally decreases what? Both solubility and boiling point. That's what we can expect, more boiling point in the case of first one than that of second one. Okay, generally what we can expect, since we have one group more, right, NO2 group is more, generally molecular weight increases, boiling point increases, surface area increases, something like that, right? But here the major considerable thing is hydrogen bonding. Next, let us take the last question here. Last question. The region for exceptionally high boiling point of water. Why we are calling exceptionally high boiling point means we have H2O and H2S, which belongs to the same group, right? Though like sulfur has more molecular weight, atomic weight, and like H2S has more molecular weight, comparatively H2O has more boiling point. Why is that? Means it is not because of its high specific heat, not because of its high dielectric constant, it is not because of its low ionization of water molecule, but it is because of hydrogen bonding. It is because of what? Hydrogen bonding. This is all about what? Hydrogen bonding. This hydrogen bonding is not only in chemical bonding chapter, right? It comes in everywhere, like it comes in organic chemistry, physical chemistry, okay? Everywhere it is there, and few of the questions have been asked based on the hydrogen bonding in the previous NEET and JEE examinations, right? That's what it plays an important role in chemistry. That's what it is more important topic for chemistry students, right? Thank you for watching. Like, share with your friends and subscribe Vidhyalakshmi YouTube channel.